Okay, so this video, we're going to go through Chapter 2, Objects and Classes. Hopefully give you a slightly better idea of what object-oriented programming is and how to properly implement it. Alright, so we got our introduction to an object. Basically, objects are entities that they represent something, and they're going to have methods or commands that they know how to do. These commands or variables that are associated with them should make sense. If I have a car object, it probably needs to have, number of wheels or body style or something like that. But miles, fuel efficiency, something like that. All of those things would make sense to be in a car class or a car object. Number of students wouldn't make sense because that's not something that a vehicle would carry. Information a vehicle should know. So the idea is we're programming. We're going to write small classes that have specific methods that do specific things, and when you want to use that, you're just going to make an object of that class so you can actually use it in the computer, and then you can run the methods, and that way we write it once and you just use it over and over again. Okay, so objects 2.2 is classes. Classes again are blueprints. Alright, so a class construct defines a new type that can group data and methods to form an object. So this would be our runner info class. So a method that sets the time, private internal data fields, instance fields, so numbers that we need to save. Currently we've worked with variables, int user num. Those don't last. Once the method is done, the computer forgets them. However, we need to have some way of storing persistent data. That is to say, every runner, I should probably not lose their last runtime when the program, moves on to the next method. So we have instance fields, which are very similar to variables, except they're permanent for however long this program is running. So I've got the same thing as a variable. I've got a type, I've got a name. And one thing we're going to add here is this access, which we're going to call it private, which means only methods of this class can touch it, so I don't accidentally override it. Okay? So I've got a class here. Notice classes don't have main. Alright, I've got a public static void main, which actually runs my program in an entire another class. So now we're going to start having more than one Java file, more than one class. One of those will contain a tester that's going to run everything, and it's going to have the main method in it. Your classes and the objects you make of those classes will just have specific things that they can do, but they're not going to be runnable. They're not going to have a main method inside of them. Okay? So to use a class, you need to create an object of that class. All right? Each object has to have a unique name. Okay? And then you're going to have a method that then knows how to do methods that it knows how to do, and you're going to call it by the name and then a period and then the method name. Okay? So for instance, we would have runner1 dot set time, and we would, in parentheses, we would give it a parameter of how long. Okay? So if you run this, photo frame, new photo frame. Okay? I have a class, so I have to identify my class name. I have to give it a object name, and then I have to use this keyword new. If you don't say new, you haven't made a new one. Okay? So and the thing is, they have to have unique names. Now they're all going to look the same. Every photo frame is just going to have the same methods, same instance fields, because they're all photo frames, so they should all be the same because that's using the blueprint. Okay, second variable definition, I make a second photo frame. Photo frames come with a width and height field. I have methods to set the height, set the width, and calculate the area. It's the same for both, but they are unique in the computer. Right? So I take my photo frame class, the computer's going to go and look where that is, and it's going to set it up all the information for that class, tag the name to it. Now, frame 1, I have the set width method right here, and I have a parameter in parentheses. Okay? It's going to be a number that the width is going to become. So I call frame 1 set width 5, set height 7. Now, the way the computer knows is I call it by name, frame 1, use the method. Now, frame 2, I'm going to call the same method, but I'm going to call the frame 2 version, and it's unique to frame 2, so the instance fields for frame 2 will get set, and I won't get confused. So those become 8 and 11. Now I'm going to print the result of calculating the area from frame 1, calculating the area from frame 2. Okay. So we don't know what's inside, but we're going to assume it's just width times height. And it's going to return a value. Okay. All right. So it's a little more read through this specific information about using classes. Don't forget to answer the questions. Okay. To define a class, you're going to give the class name. Private instance fields go at the top. Then those are always private. And then methods are public. That way other classes can get to them. Okay. Then you have to have so the public, the type of method is either going to be void, which means it's an mutator method that just does something, or it's going to have a return type. It's going to say string or int, and it's going to give you information back, the name of the method, and then any information, any parameters or information that it needs to know to run. Okay? So, we have a hypotenuse calculator. We have right triangle. Hypotenuse calculator is my main method or my tester. It's got public static void main. Creates a scanner object looking for input from the keyboard, and then it creates a right triangle object called triangle A. And remember, we're going to use the new right triangle and then parentheses to call the constructor for the right triangle. Okay, so I've got to edit these here. Okay, I'm going to make a triangle A. I'm going to set side 1 to length 3.0, and then set side 2 to 4.0, and then print the hypotenuse of the triangle A and the return method get hypotenuse. Get hypotenuse is a return method of a double type that gives you something back. Okay, and then I can use it. Right now it returns -1. That is not a legal hypotenuse, but you're going to realize that -1 is a number that is often used to indicate erroneous data so you can immediately catch it. I know in this case that hypotenuses cannot be negative. Therefore, if I see -1, I know I'm not running my program right. So, I need to define side 2. Well, I'm just going to, here, I'm going to write, and again, just copy what it says before. You've already defined side 1. Now I've got a method called, an instance field called side 2. It's of type double. Doubles are floating point numbers, that is to say, it's decimal values. Okay? Now, public void set side 1. I'm going to give you a number, and I'm going to take that parameter and I'm going to permanently save it in the instance fields. Remember, instance fields last. Method variables die as soon as the method ends. So as soon as set side 1 gets to the bottom, side val disappears. So I can't use it down here to calculate my hypotenuse. So I need to permanently save it. Remember, instance fields do not disappear. So as long as this right triangle is being run, that's going to be there. Okay? So fix me. Define set side 2. Well, it's probably going to look an awful lot like side 1. Now, two things I don't like about this program. I do not like this. I do not want you to get in the habit of writing return statements in void methods. That is going to get you in trouble on the AP exam. Do not do it. So comment it out or delete it entirely. If it says void, you will not have the word return in your method. I also am not a huge fan of putting the opening bracket at the top because I just messes me up. So now we're going to say side 2 equals our temporary side 2 parameter variable. And then close out the method. Set side 2 seems to match set side 1. And then get hypotenuse. Fix me. Temporary until side 2 is defined, because until I make side 2, I can't use it. So here we're going to, now I do want a return statement. I do need to get this is a double, so I need to return some sort of number. And I can just remove the comment, and I have return the square root of side 1 times side 1 plus side 2 times side 2. Let's run it. 3.0. Does that make sense? Well, we never set side 2 to 4, so currently it's 3 and 1. So fix me, set side 2 to 4.0. So we have to identify who we're using. Triangle A, set side 2 to 4.0. Now I have a 3, 4, should be a 3, 4, 5 right triangle. I also do not ever want to return here. Hypotenuse 5, it works. Mutators, accessors, private helpers 2.3. This is more about how we're going to use methods. Okay, methods, public methods are commonly classified as either mutators or accessors. A mutator modifies or it mutates some data. Okay, something changes. An accessor method gives you information back, or looks at or touches the data fields, but it does not change them. Okay. So we've got a couple. I've got a void. This changes. Set player 1 changes the information stored with this assignment variable in player 1 play A. So this is a mutator method. Get player 1 play A, just return the data that is stored there. This is an accessor. Okay, it doesn't change anything, it just lets me see what the current status is. Okay, also called again setters and getters, so a little bit more about that. Private helper methods are not are useful, but they are not directly tested on the AP exam. All right, 2.4. This is a big 2.4.2.5. This is a big section to understand. All right, constructors and constructor overloading. Now, when I have an object, I'm trying to make a new object. Notice I'm going to call a method, and you know it's a method because it has double open and closed parentheses. All right, that is the name of the class. That is the constructor. So when I create a new object, I'm going to say class name, object name equals new constructor method name with parentheses and any parameters that I need. Okay. A default constructor has no parameters and will set all instance fields to some sort of value. Okay. Unlike variables, instance fields will get a default value, but you never want to leave it up to the computer to set your default values. So my constructors need to handle the initialization of all my instance fields. Okay. So in this case, if you call runner info runner1 equals new runner info, and then you're going to again parentheses, it's calling the constructor. In this case, my time run field will become 0 and my distance run field will become 0.0. Constructor has the same name as the class, has no return type. Okay. Answer the questions. Define a constructor as indicated. Sample outlook. Fix me. Write a constructor. Initialize year to 0. Vehicle ID to num to -1. And your solution here. So this would be my running method. Public static void main. Again, let's get rid of that. Ooh. No, I guess I can't touch that. Write a constructor. Initialize year to 0. Oh, here we go. Fix me. So we got set year, set. Okay, so we need to make car record. It is being particular. Your solution goes right here. Public. It's got to be the same name as the constructor. Car record. And I need to find my initial instance fields. Year made, and I need to initialize it to 0. And vehicle ID num becomes -1. It's going to throw an error. I forgot to close my curly braces. So if you see this error, reached end of file while parsing, probably means you forgot to close something and the program just tried to keep running forever. Now, if you run a program in the web browser, you can't seem to reach our server. You track your internet connection. All right, well, that's lovely. And you think your answer is right. For instance, when you're drawing the cat and you have a space at the end, fine. What you need to do is you need to send me a screenshot of your output and the error when it grades it, and send me an email and tell me that you think it needs to be fixed. And if I agree, I will go back in and edit the grade. There we go. So all tests passed. So if it said something was wrong, but you thought it was right, you can screenshot it and let me know. All right, constructor overloading. I need to have more than one constructor. If I have a default runner info, well, sometimes I don't want to. I want you to tell me what the runner's time was and the distance that they ran. I don't want it always to start at 0 and have to go set it. So I'm going to write a second, a third, a fourth constructor. You can have as many constructors as you want. This is called overloading. If you have the same method name, but the computer knows which one to use because it has different parameters. So the default constructor here has 0 parameters and everything just gets set to 0. Didn't have to set it to 0. I could set my default distance run to 5 miles or whatever. Here, I override them using the parameters. So if I made runner info, class name, object name, runner1 equals a new runner info, call the constructor, no parameters, it finds the one that looks like that. Make a second object, still a runner info, runner2, has to have a unique name, is new runner, runner info, I give it 2 parameters. An integer, that is a non-decimal number, which is my time run in seconds, and the distance in miles. And then it's going to call this constructor. This yields a compile error because I do not have a constructor written yet with just one integer parameter. And this creates it in the computer's memory, but does not actually initialize it and make it yet because I have not made a new one yet. So it's sort of halfway there. All right, now I'm not going to write it, but write your own answer here. So I've got a default phone plan, and then I'm going to write with some sort of parameter here. All right, num minutes, which has to match. So it has to be an integer. Int, and I mean you want them to be useful, but technically it could even look like this. And then I can do something for y, for the free messages equals y or something like that. That's not good programming practice, although it's legal, because if you go back in later, someone's gonna be like x and y, that doesn't make sense. This is a free minutes. What is an x? You want your variables and parameters names to make sense. However, that would compile and run. All right, unit testing. You need to run your tests. Okay, you need to test bound cases. You need to test, that is to say, numbers that could be possible, numbers that could not be possible, and the numbers that are right in the middle, or cases that are right in the middle, so you can see if your decisions make sense. So if, I don't count a workout if I worked out for less than 10 minutes. If I record, then I should check a 9-minute or a 5-minute workout. I should check an exactly 10-minute workout, because that's my sort of breaking point, and I should check like a 20-minute workout to see if they pass. Okay, so this section goes over good unit testing. A reference is how to find the information in the computer. So technically, if I have an object name, runner1, or in this case, travel time, and make a new time, hour, minute, the actual data, all of this information here, all of my instance fields and their correlating data, are not actually stored inside travel time. In the computer, travel time is merely storing the address of where all of this is in memory. So the computer blocks off some memory somewhere, and it's in charge of figuring out where to put it. Just whatever happens to be open, and it tries to optimize. You don't know where it is. It allocates the memory, and then travel time just happens to actually store where to go find the beginning of all of this. Okay? So an object reference or an object name stores a reference or a pointer that points to the actual place in the computer where your object information is stored. Primitive types, that is numbers and things like that, there's a couple of primitive types that we'll learn. Those actually store inside of themselves the appropriate data.